Hello children, welcome to Math Park. Today we are going to start chapter 7 Indices or Exponents of class 9 ICSE Concise Selena, and we are going to solve exercise 7a. So children, if you like the video, please do not forget to share with your friends, and if you are new to the channel, please subscribe. So let us start with the questions of exercise 7a, and the laws of exponents. Already the video is there on the channel, so the link for that will be put in the description of this video. So we start with the first question. We'll be solving few questions similar. I want you to try yourself, and if you have a doubt, you will be asking me in the comment section. So we have 3 to the power 3 into 243 raised to minus 2 by 3 into 9 raised to minus 1 by 3. So what we have to remember, these are the fractional exponents. So now I have also created the video on fractional exponents. There also I have explained. So 243 and 9, they are some powers of 3. So what we can do is we need to find the prime factorization of 243. Divide by 3, 3 8s are 24, 3 1s are 3. Again 3 27s are again dividing by 3, 3 9s are 27, 3 3s are 9 and 3 1s are 3. So what we understand here, 1 2 3 4 5 times it is the fifth power of 3. So we write this as 3 to the power 3. This 243 can be written as 3 raised to 5 raised to minus 2 by 3 into 9 is the square of 3. So 3 raised to 2 raised to minus 1 by 3. Now we have the law a raised to m raised to n is equal to a raised to mn, right? So we further simplify 3 raised to 3 multiplied by 3 raised to 5 times 2, it is minus 10 by 3 into 3 raised to minus 2 by 3. So we have the bases same. So we have the law a raised to m into a raised to n is equal to a raised to m plus n. Using this, we get 3 raised to 3 plus minus 10 by 3 plus minus 2 by 3. Okay, so we are adding the exponents over here. So we can have the LCM here 3 upon 1. So we will be multiplying by 3 here. So we get 3, denominator is going to be 3. 3 3s are 9. So 9 minus 10 minus 2. So we get here 3 raised to, this is equal to 3 raised to 9. 9 minus 10 is minus 1, minus 1 minus 2 is going to be minus 3. So we get minus 3 upon 3. So which is 3 raised to minus 1, which is equal to 1 upon 3, because a raised to minus m is equal to 1 upon a raised to m. Got it? Let us solve the second question here. So second question is also similar. We have 5 to the power minus 4, 125. So all of these first we will write in the powers where the base should be 5. Okay. Now 125 is the cube of 5. We need not do this. Some of the cubes we should be able to know. So we have 5 raised to minus 4 into, this is 125 5 cube, and this raised to 5 by 3 divided by 25 is the square of 5. So we write this as 5 square raised to minus 1 by 2. Okay, now a raised to m raised to n is a raised to mn. So this 3 into 5 by 3, this get cancelled. 2 and 2 got cancelled. Now here let us add, this is a raised to m into a raised to n is a raised to m plus n. So solving this, we get, this is 5 raised to minus 4 plus 5, which is 5 raised to 1 divided by 5 raised to minus 1. So now this is, we put the 5 raised to 1, a raised to m divided by a raised to n is equal to a raised to m minus n. So this becomes 1 minus of minus 1, which is 5 raised to 1 plus 1, which is 2, and that is 25 is the answer for question number 2. The part of question number 1, in between I have left 2, which I want you to do yourself. This is 16 upon 81 and minus 3 by 4. So you have to look for the denominator. Look for the denominator of the fractional exponent. So there is some relation between this number and the fractional exponent, denominator of the fractional exponent. Now 16 is 2 to the power 4 and 81 is 3 to the power 4. This all raised to minus 3 by 4. 49 is square of 7 and 9 is square of 3. This raised to 3 by 2. divided by 343 is the cube of 7. So this is 7 cube, and 216 is the cube of 6. So it is 6 cube, and this all raised to 2 by 3. So this becomes 2 upon 3 raised to 4 multiplied by minus 3 by 4 into 7 upon 3 raised to 2 multiplied by 3 by 2 divided by 7 upon 6 raised to 3 multiplied by 2 by 3. A raised to m raised to n is equal to a raised to mn. This 4 and 4 got cancelled, 2 and 2 got cancelled, 3 and 3 got cancelled. So we now have, now it is 2 by 3 raised to minus 3. So if I have to make the power positive, this becomes 3 upon 2 raised to 3 into 7 upon 3 raised to 3 divided by, this is 7 upon 6 raised to. So if I have to do division here and convert this into multiplication, this becomes into 6 upon 7 raised to 2. Right? Now let us simplify this further. We can just expand it and solve it. So on expanding it, we get 3 cubes. So we'll write 3 into 3 into 3 upon 2 into 2 into 2 multiplied by 7 is going 3 times, 7 into 7 into 7 upon again 3 cubes. So 3 into 3 into 3 into 6 square, which is 6 into 6 upon 7 square, which is 7 into 7. Simplify this, 7 and 7, 7 and 7 got cancelled. All 3 and 3s will get cancelled. 2 ones are, this 3 and 3 got cancelled. 2 ones are 2 and 2 3s are 6. Again, 2 ones are 2 and 2 3s are 6. Now we cannot simplify. Numerator we have 7, 3 and 3. Denominator we are left with only 2. So multiply this, you have 3 3s are 9, 9 7s are 63 upon 2 is our final answer. So 63 upon 2 can be written in the form of mixed fraction, which can be written in the form of mixed fraction, or you can even write in the decimal. So half of 63, it is 31.5. And this is the answer for question number 5. So we did with question number 1, 2 questions I haven't done that you need to do yourself. If doubt, please ask me. We begin with question number 2. In this, we have the first one, 8x cube divided by 125y cube raised to 2 upon 3. Again, 8x cube. So what we will do it is 8x. 8 is the cube of 2. So this is 2x the whole cube divided by 125 is the cube of 5. So it is 5y the whole cube. And this all raised to 2 upon 3. Easy? Okay. Now this is again 2x upon 5y. This all raised to 3. A raised to m upon b raised to m is a upon b raised to m into 2 by 3. So this got cancelled. So our final answer is 2 upon 2x the whole square, which is 4x square, and 5y the whole square, which is 25y square. And we are done with this question number 1 of question 2. Let us solve one more here. So we have a plus b raised to minus 1 into, this dot means multiplication, into a raised to minus 1 plus b raised to minus 1. So a plus b raised to minus 1 is actually 1 upon a plus b raised to 1. So we need not write that power. Raised to 1 means it is the same. And this is into, in bracket, I have 1 upon a plus 1 upon b, because a raised to minus m is equal to 1 upon a raised to m. We use this law. Okay. Now we take the LCM here. Taking the LCM in the bracket, we have 1 upon a plus b. Let it be here. So we will have to multiply by b here and multiply by a here. So this becomes a plus b upon ab. Okay. And this is how we get this a plus b and a plus b got cancelled. Our answer is 1 upon ab. Got it? So you have done the 2 questions of question number 2. We do the third part of this. It is 5 raised to n plus 3 minus 6 into 5 raised to n plus 1 upon 9 into 5 raised to n minus 5 raised to n into 2 square. Now see children, here it is 6. The bases are not same, and here it is minus sign. So what we can do here, can I split this n plus 3 into n plus 1 and something? Yes, we can do that. So we will be having here 5 raised to n plus 1 into 5 raised to 2. What did we do? Now, if I add n plus 1 plus 2 is n plus 3 only. A raised to m into a raised to n is a raised to mn. Minus 6 into 5 raised to n plus 1. We did the numerator simplified. In the denominator, we already have 5 raised to n common. So we take this 5 raised to n common. 5 raised to n is taken common. We are left with 9 minus 2 square, which is 4. 2 square, which is 4. Okay. So now from the numerator, we can take 5 raised to n plus 1 common. We are left with 5 square minus 6. Okay. So upon denominator, we have 5 raised to n into 5 raised to 9 minus 4 is again 5. So this becomes denominator, we have 5 raised to n plus 1 and 5 square is 25 and 25 minus 6, let it be as it is, upon a raised to m into a raised to n. 5 raised to 1 it is, nothing is there means 1 is there. So it is 5 raised to n plus 1. Now what happens here? 5 raised to n plus 1, 5 raised to n plus 1 got cancelled. And 25 minus 6, what is 25 minus 6? 25 minus 6, that is 19 is our answer. Got it? This is our answer. 19 is our answer. So let us do the second part of this, fourth part of this question number 2. This is 3x square raised to minus 3 into x raised to 9 raised to 2 by 3. Okay. Now, how can we simplify this? This is x square. Okay. So what we have to do is, this is 3 raised to minus 3 is also there, and x raised to 2 raised to minus 3 is also there. So we write here 3 raised to minus 3 into x raised to 2 into 3 minus 3 is minus 6 multiplied by x raised to 9. This is x multiplied by x raised to 9 into 2 by 3. Okay. So this is 3 ones are 3 and 3 threes are 9. Right? Understood? So this becomes 3 raised to minus 3 is 1 upon 3 raised to 3. This is x raised to minus 6 into x raised to 3 twos are 6 we got. So which we get it as a raised to m into a raised to n is a raised to m plus n. So we get 1 upon 3 cube is 3 cube is nothing but 80. 3 3 are 9 and 3 are 27. Yes, it is 1 upon 27 into x raised to minus 6 plus 6, which is going to be 0. This is 1 upon 27 into x raised to 0. That is equal to 1 upon 27, as x raised to 0 is equal to 1. Anything raised to 0 is always 1. Got it? So we move on to question number 3. Question number 3, we have a root of 1 by 4 plus 0.01 raised to minus 1 by 2 minus 27 raised to 2 by 3. It's easy. So now root of 1 by 4 is 1 by 2, first of all. Okay? Because root of 1 is 1 and root of 4 is 2. So that is how root of 1 by 4 is 1 by 2. Plus, let us write this 0.01 as 1 upon 100 raised to minus 1 by 2 minus 27 is cube of 3. So 3 raised to 3 raised to 2 by 3. Okay. Now, let us simplify this 1 upon 100 raised to minus 1 by 2. If I have to make the power positive, I'll take the reciprocal of this. So this becomes half, let it be as it is. And this becomes 100 raised to 1 by 2. Okay. Minus 3 raised to 3 into 2 by 3. So this 3 and 3 got cancelled. Now 100 raised to 1 by 2 means it is the square root of 100 is 10. So otherwise we can also write it as 100 is nothing but 10 square and raised to 1 by 2 minus 3 square, which was 9 we got. So this is 1 upon 2 plus this 2 and 2 will get cancelled plus 10 minus 9. So 10 minus 9 is 1. So it is 1 upon 2 plus 1, which is 1. 1 by 2 is the answer for question number 3, the first part. Got it? Okay. We have 27 upon 8 raised to 2 by 3 minus 1 by 4 raised to minus 1 by 2 in plus 5 raised to 0. So now remember, if I have to make the power positive, we take the reciprocal of the base. Okay. Now 27 is cube of 3, 8 is cube of 2. So I'll write straight away 3 by 2 ka cube into 2 by 3 to make my work easy. Minus, if 1 by 4 raised to minus 2 is there, this becomes 4 raised to 2. Okay, if I have to make the power positive, I have to just take the reciprocal of the base, plus 5 raised to 0 is 1. Now this we get as 3 raised to 2 is 9, 2 raised to 2 is 4. So 9 upon 4 minus 4 square is 16 plus 1. So let us simplify this. Minus 16 plus 1 is minus 15. So 9 upon 4 minus 15. So 15 upon 1, we multiply by 4 to have LCM here. So this we get it as 9 minus 15 4s are 60 upon 4, which is minus 51 upon 4. This is the answer for question number 2. Got it? Moving to question number 4. In question number 4, we have simplify each of the following and express with the positive index. Okay. Now, this is 3 raised to minus 4. This is 2 raised to minus 8. Let us write this 3 raised to minus 4 upon 2 raised to minus 8 is there. And this all raised to 1 by 4. Now, if I have to take this one, we know that a raised to minus m is equal to 1 upon a raised to m. So this becomes, if I have to make the powers positive, I'll shift this. I'll take the reciprocal. So this 2 raised to 8 goes up because a raised to minus m is 1 upon a raised to m. And 3 raised to 4 comes down. And this all raised to 1 by 4. Right. Now, let us simplify this. I want the power 4 for both. Okay. So then I'll write 2 raised to 8 is nothing but 2 raised to 4 and raised to 2. Correct? Okay. So 2 raised to 4 raised to 2, or even I can write this as 2 raised to 8 into 1 by 4 upon 3 raised to 4 into 1 by 4, then also fine. So we simplify this, 4 got cancelled, 4 ones are and 4 twos are 8. So 2 square is 4. This is how 4 upon 3 is the answer for question number 1. Got it? Now here it is again simple. What you have to do? Fourth part of question number 4, we have here 1 minus brace bracket 1 minus n raised to minus 1. This raised to minus 1, the whole bracket raised to minus 1. So we will slowly solve 1 bracket. Okay. So we keep the outer bracket as it is 1 minus. First we are going to solve this one. So 1 minus this brace bracket as it is 1 minus this becomes 1 upon 1 minus n raised to 1, which we need not write here. The law we are using is a raised to minus m is 1 upon a raised to m. Okay. Now this raised to minus 1 and this whole raised to minus 1 again. Now let us keep this 1 minus. We are solving this. So LCM is 1 minus n. So this becomes 1 minus n minus 1 upon 1 minus n raised to minus 1. This all raised to minus 1. Now this 1 minus 1 gets 0. Minus of minus is going to be plus. And we will be taking the reciprocal of this. So we take the reciprocal of this. So this becomes 1 and this minus of a minus is going to be plus. And n upon 1 minus n raised to minus 1 becomes 1 minus n upon n. Okay. And this bracket is now solved and this raised to minus 1. Now let us simplify. Here the LCM we have to take as n. Okay. So here the LCM is n again. So n, so this becomes n plus 1 minus n upon n. So what we have done, we are multiplying by n over here. So n plus 1 minus n upon n raised to minus 1. So n minus n got cancelled. So we get here, I am doing it over here. So I have got 1 upon n raised to minus 1, which is equal to n raised to 1 or n. This is our final answer. Got it? 2160 is equal to 2 raised to a into 3 raised to b into 5 raised to c. Find a, b and c. Hence, calculate the value of 3 raised to a into 2 raised to minus b into 5 raised to minus c. Okay, now in this question, what we will do is we will find this is express this as the product of primes. So we find the prime factorization of 2160. So let us start dividing by 2. 2 ones are 2, 2 zeros are 0, 2 8s are 16 and 0. Again dividing by 2, 2 5s are 10, 2 4s are 8 and 0. Again dividing by 2, we get 2 2s are 4, 2 7s are 14 and 0. Again dividing by 2, I get 2 1s are 2, 2 3s are 6 and 2 5s are 10. Now 135, I'll divide by 5. 5 2s are 10, 3 down and 5 35, 5 7s are 35. This can be divisible by 3. So 3 9s are 27, 3 3s are 9 and 3 1s are 3. So we have now got 2160 as the product of primes as 1, 2, 3, 4. 2 to the power 4 into 5 to the power 1 into 3 to the power 3. So 3 is 3 times, 5 is 1 time, and 2 is 4 times. Got it? Now we compare this over here. So that is how comparing these two equations, we get A is equal to 4, B is equal to 3 because 3 ka power. Compare this. 3 ka power is B. So B is equal to 3 and 5 ka power is C. So 5 power here is 1. So C is equal to 1. Now we have to calculate the value of this. So we write 3 raised to A into 2 raised to minus B into 5 raised to minus C minus C. Let us substitute the values over here. 3 raised to A. A value is 4 multiplied by 2 raised to minus B. So it is minus 3 into 5 raised to minus C. That becomes minus 1. So 3 raised to 4 is 81. 2 raised to minus 3 becomes 1 upon 2 raised to 3 and 5 raised to minus 1 becomes 1 upon 5 raised to 1. So this is 81 upon 2 cube is 8 into 5. So this is 81 upon 40, which can be written and mixed fraction as 40 2s are 80, 2 1 by 40 is the answer for this question. Okay. Now question number 6, I want you to do yourself and put in the comment section. Okay, same way you are going to solve. Let us move to question number 7. In question number 7, we have simplify 8 raised to 3a into 2 raised to 5 into 2 raised to 2a upon 4 into 2 raised to 11a into 2 raised to minus 2a. So 8 is the cube of 2. So 2 cube raised to 3a into 2 raised to 5 into 2 raised to 2a upon 4 is square of 2. So 2 raised to 2 into 2 raised to 11a into 2 raised to minus 2a. If I take it, it will go up. This 2 raised to minus 2a, if a 1 upon a raised to minus m will become a raised to m. So this 2 raised to 2a will go up. It becomes 2 raised to 2a positive. Got it? Now we have the bases same. We will be simply adding the indices. First, this is 3 3s are 9. So this becomes 2 raised to 9a. This is 9 and this is a into 2 raised to 5 into 2 raised to 2a plus 2a. So let it be as it is, 2a into 2 raised to 2a upon denominator we can have 2 raised to 2 plus 11a. Okay, we are adding the powers 11a. Now let us simplify this further. So we have 2 raised to 9a plus 2a, 9 plus 2, 11a. So we can even write this separately. Okay, okay, let us write it 2 raised to 2 into 2 raised to 11a, so that it will be easy. Now this 2 raised to 9a plus 2 raised to 2a is 2 raised to 11a into 2 raised to 5 into 2 raised to 2a. Let us keep as it is. Denominator we have 2 raised to 2 into 2 raised to 11a. This 2 raised to 11a, 2 raised to 11a got cancelled. Now we have 2 raised to 5 minus 2. So this is we get 2 raised to 5 minus 2 plus 2a. So which is equal to, sorry, 2 raised to, I'm sorry, 2 raised to 3 plus 2a. Okay, 2 raised to 3 plus 2a. This is our final answer. Got it? Simple it was, just making the base equal, which is important. Okay. Question number 7 ka second part. This is again easy. 3, 7, we know it is the cube of 3. So we write it as 3 raised to we write it as 3 into 3, 20, instead of 27, we'll write 3 raised to 3. This raised to n plus 1 plus 9 is 3 raised to 2 into 3 raised to 3n minus 1. Denominator, we have 3 raised to 3n. Let it be 8 into 3 raised to 3n as it is, minus 5. 27 is 3 raised to 3. So this becomes into 3 raised to 3 raised to n. So in the numerator, we have this is 3 into 3 raised to 3n plus 3. This is 3 raised to 1 plus 3 square into this becomes 3 raised to 2. When I add, this becomes 2 plus 3n minus 1. This is 3 raised to 3n plus 1. Got it? And denominator, we have 3 raised. This is going to be 3 raised to 3n. So 3 raised to 3n will be taken common. So let it be now. One more step we will have. 8 into 3 raised to 3n minus 5 into 3 raised to 3n. Up to here clear? Again, in the numerator, we have, it is 3 raised to 3n plus 4. Okay? 1 plus 3, 4. Plus 3 raised to 3n plus 1 upon, we will have 3 raised to 3n taken common. In bracket, we have 8 minus 5. Okay. Now, this can be split so that this 3 raised to n can be cancelled. So, in the numerator again, we will have 3 raised to 3n into 3 raised to 4. I am splitting this. A raised to m into a raised to n is a raised to m plus n. Plus, this can be written as 3 raised to 3n into 3 raised to 1. And denominator, we have 3 raised to 3n in bracket 8 minus 5, which was 3 now. Okay. Now, this in the numerator, now we will be taking 3 raised to 3n common. So, we take 3 raised to 3n common. We are left with 3 raised to 4 inside the bracket plus 3 raised to 1, which is 3. Denominator, we have 3 raised to 3n into 3. This 3 raised to 3n and 3 raised to 3n got cancelled. 3 raised to 4 is 81. 81 plus 3 upon 3, which is 84 upon 3 divided 3 2s are 6, 3 8s are 24. We got it as 28. Got it? Let's move on to the next question. Show that a raised to m upon a raised to minus n, the whole raised to m minus n into a raised to n upon a raised to minus 1 raised to n minus 1. This all we have to show as 1. Okay. Now, this is easy. What we will do? 1 upon a raised to m minus n is going to be a raised to n. So, this becomes a raised to, this is going up, a raised to m into a raised to n. This all raised to m minus n. Got it? Into, again, this a raised to 1 will go up. So, this is going to be a raised to n into a raised to 1. This will be up. This all raised to n minus 1 into a raised to minus m will go up. So, it is a raised to 1 into a raised to m. It becomes positive. And this all raised to L minus m. Sorry, not. It is 1. It is L. It is L. Okay. And this is L. I'm sorry. This is not 1. This is L. And this, so we are solving the LHS now. Now, this is a raised to m into a raised to n is a raised to m plus n. Correct? This is multiplication. So, this becomes a raised to m plus n. So, inside it becomes a raised to m plus n. This raised to m minus n. Okay. Into this becomes a raised to n plus l raised to n minus l. Into this becomes a raised to L plus m, this raised to L minus m. Okay. Now, this a raised to m raised to n is equal to a raised to mn. So, this becomes a raised to m plus n multiplied by m minus n. This becomes a raised to n plus l multiplied by n minus l. And this becomes a raised to L plus m multiplied by L minus m. Now, recall the identity a plus b into a minus b is a square minus b square. So, this becomes a raised to m square minus n square into a raised to n square minus l square into a raised to l square minus m square. Now, we have the base same. We will be using a raised to m into a raised to n is equal to a raised to m plus n. We will add all the powers. So, we get a raised to m square minus n square plus n square minus l square plus l square minus m square. Got it? M square minus m square went minus n square plus n square minus l square plus l square. So, we got this as a raised to 0, which is equal to 1. So, we started with LHS. Okay. And this is our RHS. This is how we proved LHS is equal to RHS. We hence proved that the expansion is 1. Got it? Moving to question number 9. If a is equal to x raised to m plus n, a is equal to x raised to m raised to n plus n into x raised to l, b is equal to x raised to n plus 1 into x raised to m, c is equal to x raised to l plus m into x raised to n. So we get a is equal to x raised to l plus m plus n. We add this. Okay. We are using the law a raised to m into a raised to n is equal to a raised to m plus n. That's it. Same way we get b is equal to x raised to again n plus l plus m. So we write l plus m plus n. Got it? And we get c is equal to x raised to again l plus m plus n. So we can write l plus m plus n. Got it? Now we are to prove this part. So let us take this one. So we have RHS of this. We'll take RHS of this, which is a raised to m minus n into b raised to n minus l into c raised to l minus m. Now, in place of a, we will put this. We write x raised to l plus m plus n. In place of a, we are writing raised to m minus n into, in place of b, we will write again x raised to l plus m plus n. This all raised to n minus l into, in place of c, we will write x raised to l plus m plus n. This all raised to l minus m. Okay. Now we have the law a raised to m raised to n is equal to a raised to mn. Right. So we write this as x raised to l plus m plus n multiplied by m minus n. Okay. Same way here we will be writing into x raised to l plus m plus n multiplied by n minus l into x raised to again l plus m plus n multiplied by l minus n. Got it? Now we will be using the law a raised to m into a raised to n is equal to a raised to m plus n. So we write x once, we add all the powers. When we are adding all these powers, we can see that we can take l plus m plus n common. So L plus M plus N is there in all of these, so taken common. If I take L plus M plus N from here, here I'm left with M minus N. From here I'm left with plus N minus L. And from here I'm left with plus L minus M. Okay, so we get M minus M got cancelled, minus N plus N, minus L plus L. So we get this L plus M into 0. So this becomes x raised to 0 and which is equal to 1. Thus we have proved LHS is equal to RHS. Got it? The last question. And from here, I have taken the second part of question number 10. Same way you will be doing the first part. So understand this part. It will be easy for you to understand the first part. Okay. So that you can put in the comment section. So we have x raised to a upon x raised to b minus b. So we'll be subtracting a raised to m divided by a raised to n is equal to a raised to m minus n. So this is going to be x raised to a minus of minus becomes plus b, a plus b raised to a square minus ab plus b square into, this is going to be x raised to b minus of minus c becomes b plus c, this raised to b square minus bc plus c square into x raised to minus of minus plus a, so c plus a raised to c square minus ca plus a square. Recall the identities. So now a raised to m raised to n is equal to a raised to n. So we x raised to a plus b into a square minus ab plus b square into x raised to b plus c multiplied by b square minus bc plus c square into x raised to c plus a multiplied by c square minus ca plus a square. Okay. Now this is the expansion of a cube plus b cube, right? So this is the expansion of a cube plus b cube. So we get x raised to a cube plus b cube into x raised to, again we get here b cube plus c cube. This is the expansion of b cube plus c cube into x raised to, we get here a cube plus c cube. Got it? So this is how we get now x raised to, we'll add all of this, we get a cube plus a cube, we are getting 2a cube, 2 in bracket a cube plus b cube plus c cube. But because we have 2b cube, 2c cube and 2a cube. Got it? So this is what we get it as a raised to 2 in bracket a cube plus b cube plus c cube. And this is the expansion of the given question. Got it? Same way you will be able to do the first one. Same type of identities are to be done. Okay. So children, if you like the video, please do not forget to share with your friends. Thank you for watching. Have a good day.